Okay, so for the moment you've all been waiting for, we are finally going to prove the derivative of the sine function. So before we do anything, we have to reach an agreement. And that agreement here is that the limit as x approaches 0 for sine x over x is equal to 1. There's a proof for this, but I don't want to do it. So we're just going to assume it's true, and yeah, that's good enough for now. And we're going to start the proof now. So we're going to start with f of x, which is equal to sine x. And by formal definition of a derivative, we can write this as the limit as h approaches 0 for sine x plus h minus sine x all over h. So hopefully in trig class, you've learned that sine of x plus h can be rewritten as sine, cosine, cosine, sine. So sine x cosine h plus cosine x sine h minus sine x all over h. What we're going to do now is factor out sine x, and we get this lovely thing. All over h. And we're going to split this into the sum of two limits. So we have the limit as h approaches 0 of sine x cosine h minus 1 over h plus the limit of h as h approaches 0 cosine x sine h over h. And since we know that as h approaches 0, we can get cosine approaching cosine 0, which is equal to 1. So 1 minus 1 is equal to 0. So this whole thing, as h approaches 0, this thing approaches 0, and since we're adding this, we can basically cross that out. And then now we're left with this part. Let's rewrite this as the product of two limits. Remember that agreement we made earlier? Well, here it is again, except with h's instead of x's. So we know that this approaches 1, right? Yeah! So this, since it's multiplication, if we're multiplying by 1, it's pretty much the same thing. So now we're left with the limit as h approaches 0 cosine x. But wait, there is no h, so this part doesn't matter. Well, h does not matter for this function. So what we are left with is cosine x. Oh my gosh, we know that the derivative of f of x is equal to cosine x. Ta-da! Yay!